All right, so the first page, you're either naming the arc or the angle. All right, and so if an angle is given, name the arc that makes it. If an arc is given, name the central angle. And so they've given you this major arc EFG. And so you want to make sure you know what they're asking about. They're asking about E to F to G. They want the central angle that makes that. Well, that's going to be E to Q to G. And so you're going to tell me angle E, Q, G. That's all you're doing for those. Now, if it specifically says the major arc that's made by this angle, make sure you give me the major arc. If it just says an angle, then it wants the minor arc. So if it gives you an angle, you're giving me the arc. If it gives you the arc, you're giving me the angle. Okay? Vice versa. You're just giving me the other one. So if it's asking for an angle, do your angle notation with 3 letters. If it's asking for an arc, do your arc notation. A minor arc is 2 letters, a major arc is 3. Okay? The next group tells you that they want you to find the measure of the arc or angle that is missing or that they're asking for. In this case, they want the arc. Specifically, they want the arc RVT. That's what they're asking for. So they want R to V to T. Okay? And there's actually a couple ways you can do this. If you find what you don't have, you can subtract from 360. Or you can add up of the ones that you have. And so personally for this one, they want the entire circle except for this piece right here. And I already know part of this piece. So they basically want 360 minus that piece, okay? And so if I can figure out what that piece is, I can just take it from 360 and go from there. Or I can say I have these 2 pieces. So there's a couple ways to do this. You have these 2 pieces here plus this one. And so you can solve this multiple ways as long as you know what you're looking for, okay? And so as long as you know what you're looking for, you can say, I can solve it adding up all the pieces I want or taking 360 and subtracting what I don't want on these. And sometimes you're just going to have to do it from 180 because the only thing that you're missing is something that's in a 180, all right? And so for this one, you can either figure out what that is and subtract him, or you can say, well, I have all that I need except for the one little piece that I can add in. And so if I look at this, I'm going to figure out which way I want to solve it, and then I'm going to solve. So for this, I'm going to say, well, I know that this piece right here is half of a circle. So how much is this part of it? So that part's going to be 180. The next part was given to me. How much is this part? They gave it to me. How much is it? 84. So I can just take those 2, right? And I can add them. And so I double check. They wanted R to V all the way around to T. And that's what I gave them. I gave them those 2 pieces that add up. All right, so for 9 through 12, they want you to solve for X. For the first set we just did, it's all numeric. But just conceptually, you're doing the same thing. So for this one, they want you to solve for X. And they actually made it way easier than what you even have to. They gave you way more information than you need. Okay? So first of all, let's look and see where X is. Well, X is part of this central angle right here. All right? So X is in this piece. And they gave you all these other pieces to this circle. But what's the only thing you actually need here to solve for X? So all that other information is extra. You can just use this 60 right here. I mean, if you wanted to like try to do the 360 and all, you could try, right? But you literally just have that central angle and they told you it's 60 degrees. So you can just set the 60 equal to the 6 plus 9x, and you can solve. Subtract your 6, you're going to get 54 equals 9x. divide by 9, you're going to get x equals 6. And you are done. That's all they ask for. The next group deals with chords and radius, and the chords being cut in half pretty much. So for this one, they have given us a couple pieces. They've given us this 5.6 over here. They've given us this 12.5. They want us to solve for this. What method are we going to use here? Yeah, Pythagorean theorem. So I'm going to say a squared, that's my 5.6 or my 12.5, plus b squared equals c squared. All right? Biggest two mistakes that I have with these problems: you either put your c in the wrong place. Your c is always, always, always your hypotenuse, okay? Always the longest side, the side across from your right angle. That's the number one problem. The number two problem is getting to the end of it and not taking the square root, okay? So if on your quiz I put take the square root, it's because you did not finish, all right? When you set it up like this, you're solving for x squared and it's asking for x. So make sure that once you do your square and you add them, or subtract depending on which way it's set up, that you take the square root, okay? And once you take the square root for this particular one, I believe your answer was 13.7. It says to round to the nearest tenth. So 13.7 is what you should have gotten here. If you'll remember, this theorem says that if you have a tangent and a radius, they're going to be perpendicular. So even though they didn't tell you that this was a right angle, you automatically know that this is a right angle. And so once again, you can use the Pythagorean theorem. I would say pay attention to what they have given you. They have given you this 5.6, but that is just the radius. All right? So on some of these, they give you the diameter, and those arrows show you that they gave you the entire line. If they give it to you like this, just on one side of the line, then because it's a radius, you know that other side is also 5.6. Okay, so make sure that you don't just do the 5.6 as your number that you're going to square. You actually need to do 11.2 as your number that you're going to square. Which side is your C? You have the variable over here that you're looking for. This piece is 11.2 when I add it together, and then I have the 14, which is my C. Which is my C in my a squared plus b squared equals c squared. It's my 14, okay? It's my 14. When you set this up, you set it up correctly. 11.2 squared is what you're going to square, not the 5.6. What you're looking for, that is also a leg, and your hypotenuse here is 14 squared. And once again, make sure you take your square root. When you solve that out, you're going to square, subtract, take the square root. You should get 8.4 here as your answer. Next one uses the information that we know that two tangents that intersect outside the circle are the same distance away from your circle itself. And so for this, they want the perimeter. So if you know that this is 14, then this piece is 14. If you know that this is 13.4, then you know this is 13.4. And the other piece of this, some of y'all got a little confused on this on your quiz. If this is 6.8, then this part of this side is going to be 10.9. I mean, it's going to be 6.8, sorry. And the remainder is going to be 10.9. So this piece is 6.8. This piece is 10.9. Because together they're 17.7, which helps you get this piece right here of 10.9. And so you're just working around the figure to get all the pieces that you need. And then you add up all those pieces. So you're going to add the 14, the 13.4, 13.4, 10.9. You can add the 17.7 here because you know that's the whole side, 6.8 and 14. And when you add that all around, you should get 90.2 as your perimeter. So this next group uses the same theorem that those tangents are equal. All right, tangents that intersect at the same point on the outside are going to be equal. So you actually don't need the 23.9 at all. All you need is the fact that 5x minus 5 equals 4x plus 5. All right, subtract your 4x over, and then add your 5 over. So you're going to get x equals 10 here. You do not need the 23.9 at all. All right. This is asking for the length of the arc. Length is the distance around. So you're going to start with the distance around the entire circle, which is your circumference. What is your circumference formula? What's your circumference formula? 2 pi r. All right? And then you have to take into consideration that it's only part of it. So you're going to use your angle that they've given you over 360 times 2 pi r. That is your formula for this group. So in this case, my angle is 270. So I have 270 over 360 times 2 pi, and my radius is 4. So you're just giving me the length. You do round to the nearest tenth, but you should be able to do all of that in your calculator. 18.8 centimeters is the length of that arc. You do have to know this formula. So you want to know that formula right there. So this next section is all about inscribed angles. Remember, central angles equal the arc length, but inscribed angles are half of the arc, okay? Half of the arc measure, not length, rather. And so they want this right here, which means I need to know this arc. They've given me everything except that arc. So a whole circle is how many degrees? 360. So I'm going to say 360 minus the other two pieces, which is the 150 plus the 98, right? And when I do that, I get 112. That gives me this right here, all right? I need the angle measure. Well, the angle measure should be exactly half of that arc measure. So I'm going to take that and I'm going to divide it in half. And I should get an angle measure of 56 degrees. And my x that I'm looking for is right here, which means I really need the arc measure that's made from this angle. So pay attention to the angle that I'm talking about. I'm talking about this angle, all right? So the arc that I need is this arc right here, all right? They've basically, once again, given me everything except that. Everything except that. So I'm going to do exactly what I did on the other one. I'm going to take 360 minus the 76 plus the 68. All right. And then that's going to give me what I need for that arc. So this arc, to solve for it, I'm just going to take the whole circle minus the other two pieces that I don't need. So this arc measure is 216. That is the arc measure that is made by the angle. Now, that angle, however, is half of that. So I need to take that and divide it in 2, which gives me 108. So that means the angle is 108. So 108 should equal the angle measure here. All right. All right, so if I add my 3 and then divide by 37, I'm going to get x equals 3, which is all they were asking for. Solve for x. Solve for x. All right, so remember, if they intersect on the outside, it is half of the subtraction. Half of the subtraction. If they intersect on the inside, it's half of the addition. Okay, half of the addition. And if they intersect right on the circle, it's going to just be 1/2 the arc measure, period, because you only have one arc that's being created. So for this first one, you'll notice they intersect on the outside. Here we go. It's on the outside. So this angle should be half of the subtraction of these two. So if I'm looking for the angle measure, that should equal half of these two subtracted, 180 minus 60. So 1/2 of 120, that angle measure should be 60 degrees. They intersected on the outside of my circle. If they intersect on the inside, I have two arcs that are created. So this next one is a little bit different. They've intersected on the inside. And so I'm looking for this arc in particular. That 82, that angle should equal half of the sum of those, 64 plus x, all right? And so I'm going to multiply both sides by that 2. and then I'm going to subtract the 64. So that arc measure should be 100 degrees. And you can double check it. 100 plus 64 divided by 2 is 82. And so if they intersect on the inside, it's the half of the sum. If they intersect on the outside, it's half of the difference. Half of the difference. And the only difference between this section and the next section is instead of just all numbers, they now throw variables in there. And so this next section says solve for x. These intersect on the outside. So that means 40 should equal half of the difference. Half of the 34x plus 2 minus the 58. And so once again, I can just multiply both sides by 80. I can combine my like terms here. 34x plus 2 minus 58 is minus 56. I can add that over and divide, and I should get 4. I should get 4 there. So once I've done this and I've set this up, the biggest problem is potentially just your algebra. So pay attention to what you're looking for. They want this arc measure, this angle measure. In order to find it, we need this arc, but they gave me information on the other one. So 360 minus that other one gives me the arc I need. This angle is 1/2 of that arc. So 1/2 of that arc should equal this angle. Now I'm just doing basic algebra, okay? But pay attention to what I'm doing. Because I'm subtracting the group, I need to distribute that negative through. So it's 360 minus 20x minus 32 on the inside here, okay? So don't get confused with your negatives here. And the other piece that you're gonna really look at is this 1/2. So to get rid of the 1/2, I am gonna multiply both sides by 2. So multiplying by 2 gets rid of it right here, but then I need to multiply this side by 2 as well. You are multiplying the entire group by 2. So 2 times that entire group to get rid of that half on the other side. So 2 times that entire group equals this guy right here, because I canceled out the 1/2. So 360 minus 32 gives me what, 328 minus 20x, and then distribute this 2 through on the other side. So if I distribute that 2 through, I get 64 plus 4x equals 328 minus 20x. All right. So I'm going to move all my variables to one side, all my numbers to the other. I'm going to move my 20x over here. And I am going to move my 64 over here. And then divide by 24, you get x equals 11. Now, I'm not done. So this is where a lot of people will stop and then they'll get points off, okay? So once you've solved for your x, they have asked me for an angle measure. They've asked me for an angle measure here. And so I have to go back to what that angle was. That angle was 32 plus 2x. So to solve for that, I need to plug in this x that I just found. So I'm going to say 32 plus 2 times 11, or 32 plus 22. And so my angle measure is actually 54 degrees. Now I am done. I have solved for what they asked for. So just pay attention to your directions and make sure that you always know that you have answered the question once you're done with the problem. All right, my circle formula is x minus h squared plus y minus k squared equals r squared. Remember, your hk is the center, and your r is your radius. Okay? So this next group is just saying, give me the center and give me the radius. That's all this group is asking for. So my center It's going to be the point HK. What is being subtracted here? That's 10. So that's 10. What is being subtracted here? That's actually -5, because remember your original was minus. Okay, so your original is minus. So your H and K are going to look like opposite of what's in there. So this was subtracting 10, so I use +10. This is adding 5, so I'm going to use -5 as my center. Okay, because your original equation is subtraction. All right, your original equation is subtraction. So when you give me the center, it looks like it's the opposite of what is given to you. All right, my radius. This is my radius squared. So my radius here is the square root of 80. Now it wants it in radical form. So you're going to have to go back to what we did to simplify radicals. Remember your factor tree? 2, 40, 2 and 20, 2 and 10, 2 and 5. All right, remember how we did our factor tree. So remember, if it pairs up, it can come out. I have a 2 that can come out here. I have another 2 that can come out here. I have a 5 that has to stay in. So 2 times 2, my radius is going to be 4 square root of 5. That is my radius. That is my center. So this is flipping it. It's saying, okay, here is some information. Now give me the formula. So you're still going to use the same formula. You're going to use x minus h squared plus y minus k squared equals r squared. All right? The first group's really simple. They give you the center and they give you the radius. So you literally just have to plug it in. So if my center is -11, -29 over 2, then I'm going to say x minus -11 squared plus y minus -29 over 2 quantity squared equals r squared. And then you want to simplify that. Minus a negative, what should that look like? Should look like plus. This is also minus a negative. You leave it just like this. Don't square it. Don't do anything there on the inside of those parentheses. You just simplify it if it's minus a negative. You do want to simplify your 2 squared. That should just be a 4. And that's all it's asking you to do. Just write the formula. Plug in your center, plug in your radius. Tell me what it looks like simplified, okay? It's just like when we had y equals mx plus b, and I gave you the m, and I gave you the b, and I said, give me the linear equation. You just had to plug them in, okay? Same thing here. The next one's a little more difficult just because they didn't give us the radius. We have to solve for the radius, okay? They've given us the center, -2, -4, but they didn't give us the radius. So we're going to use that other xy to plug it in and just figure out what the radius is. So we're using the same exact formula, but they've given us an x and a y instead of the r. So we're going to plug this in and just solve for our r and then rewrite it. So I'm going to say, well, x minus h, remember center, this is h, this is k. So my x is 5. So 5 minus a -2 squared plus my y is 0. 0 minus a -4 squared equals r squared. I'm just plugging in my x and y and my h and k because I need to solve for r. All right. What is 5 minus a -2? 5 minus a -2 is what? 7, and then 7 squared is 49. And then 0 minus a -4. What's 0 minus a -4? It's just 4. And then I square it. I'm going to get, what, 16? And that equals my r squared. R squared. All right? I add my 49 and my 16 and I get 65. Now, my formula, pay attention here before you start doing extra work that you don't need to do. My formula actually calls for r squared. All right? If I had said solve for r, you would need to take the square root. But in this case, your formula asks for r squared. It's different than the Pythagorean theorem where you have to take the square root. it asks you for the r squared. So you just need the 65. So now we have my h, we have the k, we have the r squared. So just rewrite your formula plugging those in. So you're going to say x minus my h, which is -2. So it's going to end up being plus 2 minus a negative squared, plus y minus my k, which is -4 minus a negative is plus 4, equals r squared, which I've already solved for. So I'm just going to write 65. And that is my answer. I am done with that one. HK r squared. That's all I need to plug in when I'm telling you what that formula is for the circle. The equation for the circle looks just like that. And so for the last one, if they give you a picture or a graph, you literally just have to find the center on the graph and count for your radius, right? So my center on this graph is right here. That means my center is at -3, -1. That's where that point is, right? -3, -1. So that means my HK is -3, -1. They've given me my H and my K. My radius, well, that is the distance from the center to the side of the circle. The distance from my center to the side of the circle is 1, 2. So my radius here is 2. That's exactly like number 57 above that we just did. They just gave you a pictorial center and radius instead of giving you the numeric one, okay? So now you're just going to plug it into your formula. You're going to say x minus h minus a -3, so that's going to be plus 3, plus y minus a -1, y minus k, so plus 1, equals r squared. Well, 2 squared is 4. So that is what my formula looks like for that one.